Hi, Dr. Brian Mills from Mountain View, California, and welcome to Exocad for the Restorative Dentist. A couple of housekeeping things first. I'd recommend that you play this back at 1.5 to 2x. Also, if you want to skip through the lecture portion, you can just go to the timestamp below and you'll be into the Exocad technique portion. And last, you'll notice that I make a numeric flub during the estimated hinge axis exercise. Please ignore it and just focus on the technique. So let's get started. One of the critical things when you're doing comprehensive care for your patient is to have accurately mounted models, and you can do that in the digital world or the analog world. What you'll find when we're done is that it's much easier and as accurate, if at times not more accurate, than doing an analog mounting. So there are basically three analog methods. The first is the Coyce facial analyzer, and then we have the estimated hinge axis or estimated face bow, and last is a kinematic face bow, and they all have varying levels of accuracy. So let's start with the Coyce facial analyzer at first. It's based on Bonwell's triangle. Bonwell's triangle is a 4-inch equilateral triangle that goes from the condyles down to the lower incisal edge, and it typically has a measurement on average of about 100 millimeters. But how do you determine the angulation or the inclination of Bonwell's triangle? It is Bockwell's triangle, and is the inclination of Bonwell's triangle to the occlusal plane. And what they found is when they measure it, that it typically has a range between 22 and 30 degrees with an average of 26 degrees. So if we just take a look at an initial Exocad mounting, it is called an average mounting, and we slice it in half so we can take a look at the midline, and then let's go ahead and measure what we actually have here. So if we measure from the condylar element down, you'll see that we have essentially 100 millimeters, or Bonwell's measurement, Bonwell's triangle. And if we take a look at the right triangle that's created by that measurement, we see that it comes out to be 24 degrees. So if you do absolutely nothing, you just do an average mounting with an Exocad, you're going to have a functional plane of occlusion Coyce mounting. Since you're not using the Coyce plate, which also provides the aesthetic plane of occlusion, it's a functional plane of occlusion. Next is our ear bow or estimated hinge axis mounting. Most of the ear bows are based on some of these measurements, the estimated hinge axis measurement, but you can also mark these landmarks on the surface of the skin. And if you do that, what you'll be able to do is, with taking your Coyce facial analyzer, and instead of just using that only, you can actually mark the estimated hinge axis and then measure down and out to the incisal edge. So if we've done that, you can go into your articulator and then you can do the measurement down and out to the incisal edge. So you have an estimated hinge axis mounting within the Exocad digital articulator. It's still a functional plane of occlusion at this point in time. If you have a CBCT of the patient, you can do the exact same measurement. So we have our patient here, and we have our measurement, 3985, and in this case we happen to have a CBCT. So if we go ahead and take our CBCT, slice it in half and measure down and out, you can see it's virtually the same as if we had just done it using our Coyce plate. Last and the most accurate way to mount a case is using the kinematic face bow. And there are various types that will measure the hinge axis and the movement patterns in three-dimensional space. Anyone that's had the pleasure to do this realizes it's a very technique-sensitive procedure and time-consuming. But in the digital world, we have the Zebris jaw motion analyzer system. And what that is that you essentially have a face bow that's mounted on the top with infrared cameras and a sensor on the maxillary arch that we use optical triangulation, and we can mount the upper arch using this digital face bow. So it's quite easy to do. Right now you go ahead and you put up the maxillary arch. I'm just doing a quick demonstration how simple it is. And we can measure the maxillary arch as it relates to the hinge axis. And we can measure the movement forward, backwards, side to side. And with that, we have recorded the mandibular movement and can analyze it. So if you do an axiopath or a kinematic face bow or a hinge axis recording, essentially what you're doing is you're locating the hinge axis. And then basically the technique is with a series of 3 different bites, CR bites, at 3 different verticals, you confirm the arc of opening and closing. Well, in the Zebris, essentially you're measuring the arc first and then calculating the axis. So let's start by just doing a basic mounting in Exocad. So we're prompted to go ahead and load our upper jaw and our lower jaw. As usual, just go ahead and orient your model properly. And we'll just follow the wizard steps initially here. And again, we're just going to do a basic mounting. You can do 2 ways. You can either bring this up and orient it like this, pretty closely onto the platform. Get really close and as bright as you can. If you have trouble with that, instead, let's go ahead and put it back down here. You could go to automatic and you have 3 points to set. So for that, let's go ahead and turn that off. And you can see it's going to tell you to set an incisal, left and right molar, and perform the alignment, and then hit manual. And when you show it, see it's up on the occlusal plane that you'll be working from. So once it's here, just do your normal, those are the 2 interiors, these little brown areas here, and go ahead and line up your midline, and then just holding control, you're going to finish lining up your models here as best you can. Now this guy is pretty asymmetrical because he's missing buys on one side only, so we'll do our very best. Okay, and so you can see we're not going to get perfect symmetry with him, as I said, but we look at the incisors, we look at the canines, it's pretty close. I think for him, this is about as good as we're going to get. As you can see, he's got 1 premolar over here and 2 over here. And we can see that he is a little bit asymmetrical. So if you do absolutely nothing else, you have a coist mounting that is in a functional plane of occlusion because you don't have your coist plate that would incorporate the aesthetic plane of occlusion in it. Go ahead and cancel this. And here we are back. We reorient us. Now we'll do a mounting using our coist plate that we took chair side. And this one is just simply easier to go into expert mode because before we move on from much past this, we're going to go ahead import a mesh. So we're going to add remove mesh. And the easiest thing to call the coist plate is a generic visualization, and we're going to load it. And it doesn't matter. So let's just turn off our lower. Now, you can orient this either way. So you can orient it. So essentially move this model on top. So when you look, you're going to look down through it. Okay. And now see, there's the model. And if it's kind of like looking down into an impression. And some people don't like that. They prefer to do it this way. You're going to just click the exact points here. So let's go ahead and just do it. So there's your floating mesh. Take a couple points there. And just go ahead and perform your alignment. Best fit matching. And you can see we got a really good alignment. So this would be just fine. The other way is essentially you're going to flip this plate around so that you're looking down on the teeth. Now, if you notice, this side is now here. This side is over here. So you're basically going to flip this into the Kois bite plate. So it's still the same deal, and you'll get the same result either way. So this and perform alignment, best fit matching. And once again, you get the same alignment. So it makes no difference if you want to look which direction you want to look through the mesh to align this. Okay, so we're going to hit OK. Okay, we're done with that. And now we have a nicely aligned model into the Kois plate. All right, so just continuing in Expert, we're just going to go to our articulator. Now you can see we're going to turn this on and see it's right there. And then we're just going to go ahead and turn on this doodad. Now, if you remember, this occlusal plane is essentially a Kois plate. So what we want to do is we're going to align this so it's parallel with that and centered. And so the easiest way to do that, for me at least, is I go ahead and turn this, and we'll turn that off, and we'll click over on this, get that way, zoom in. So we're just looking through the Kois plate. We're going to center it on the platform, essentially, just as if you were doing it in the lab on a regular Kois mounting stand. Okay, so midline's on. I look at the canines, they're pretty close. And then we start getting asymmetries all the way back. So now just go ahead and look up from the side. And it's a lot easier to actually have this grid on when you're doing this part here. And we can see, double click both, otherwise you're going to move the model. If we line it right up on this line, you can see there's a little discrepancy here. And so we're just going to go ahead and just flatten that a little bit. So exactly right. And then we want to make sure we don't have any yaw or can't. So again, we're going to line it right up on the line. And we can see this is tipped. Yes. And so we're just going to do, level that out a little bit. And turn on your articulator. And there you have a nice mounting. Now, this is just a plain Kois mounting, but now with an aesthetic plane of occlusion incorporated into it. But if you recall, we did take a measurement of the estimated hinge axis. So what we're going to do is go ahead and reset this model so that it reflects a more accurate mounting with an estimated hinge axis. So to do that, the easiest thing to do is go ahead and section this to about the midline, turn on your measuring tool, and we're just going to take this measurement here, and we're going to take right from the center of the condylar element and zoom in down here, and we just want to catch this little edge right there. And you can see we have our 100 millimeter, essentially 101 millimeter reading, a basic Kois mounting. Imagine a plate is down here. But we know that we measured down 38, and that's at 41, and we measured out, once we measured from the hinge axis mounting on the side of the patient, we measured down and out to the incisal edge of the plate. So we know that measurement was 89. So we're just going to move this in a little bit. So 88.96. Let's just call it 89. That's more accurate than you're going to see if you're trying to measure it with a Bowley gauge. Now we're going to do the vertical. It was 38. So we're just going to move in. 37.9. 88.1. We'll call that good. Okay. So 38, 88. And now we have an estimated hinge axis mounting. That's down the midline of the patient right there. Okay. And there you have it. So there's our mounting with an estimated hinge axis. The plate is nicely mounted horizontally in the facial direction, and in the lateral view, you can see we're mounted nice and horizontally on the plate as well. And when you turn this off, SC mounted estimated hinge axis mounting with an aesthetic plane of occlusion incorporated. From here, you'll be able to do most of your work. If you'd like further information, please go to biosthetics.com. And if you like the video, please give it a thumbs up and also subscribe. This is Dr. Brian Mills from Mountain View, California, and welcome once again to Exocad for the Restorative Dentist. Take care.